Over the last 10 years or so, devices such as this, IP webcams, have become really popular. Whether you use them as a baby monitor, as a security camera, or for any other reason why you just want to keep an eye on something, they're really useful devices. However, they've encountered a few problems over the years, either by browsers changing, or by the technology that underpins them changing, or just purely through security concerns and privacy issues. But what you can do, in most cases anyway, is actually grab the video stream from these cameras directly, putting you in control of it, rather than you being at the mercy of the software that it comes with. Let me show you how. Hello once again, Pi geeks and techno nerds all around the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. In my spare time, I love playing around with Raspberry Pis, and I want to share with you some of the projects that I've been able to put together. If you like what you see on this channel, please hit that thumbs up button, subscribe to see more, and also hit that notification bell so you can be told when I put a new video out. And let me know in the comments both how you get on with this project, and also if you've got any suggestions for projects for me to do in the future, put those in there as well. Now let's get started. IP web cameras have been around for a very long time now, and most of them are actually reasonably cheap, especially models like this that you can pick up for around 20 to 30 pounds. But these models do come with a downside. Firstly, the software that they come with can be a little bit old and may not work very well with modern day browsers, so especially if you pick one up second hand, you can run into issues. Here is an example with the camera I was just holding up. In this case, it tries to use an ActiveX plugin to view the video stream. However, these haven't been supported on browsers for some time now, and that means that you can't view the live video through the browser. And no firmware updates have been made available for the camera to make it work using some other technology. Equally, with some brands of cameras, you may not particularly trust them. They could be from manufacturers that you've never heard of before, and you don't know what they're doing with your data. Remember, with a lot of these cameras, you've got to enter things like your home network details, usernames, passwords, that sort of thing. Let alone the video stream contents itself. You have no idea what they're doing with it. Now typically, if manufacturers make functionality available for you to be able to view the streams externally from anywhere in the world, they normally do it by having the video stream posted up to a central server. And again, that just raises other security and privacy concerns because you have no control over the data at that point. Now of course, if you're using something like Amazon's Ring system, then things are quite different. It's a much more reputable company, and they are held to account by different government agencies all around the world. However, do you really know how the video is being used? Do you really know if they're using it to help train their recognition AI engine? It's not like Amazon have never been in the headlines before around dubious use of private data. So I personally like to be in as much control as I can. So what's the solution to this? Well, what you can do in an awful lot of cases is actually gain access to the video and audio streams directly. And with that, you can then be in complete control of how you capture that video stream and how you make it available. Indeed, you can typically completely block any outgoing access to the internet from your camera at all, and run something like a Raspberry Pi that is taking in the video stream and then making it available based upon your own rules and your own infrastructure. And that's what I want to do in this video. I'm going to take the IP camera that I was just showing you, I'll take the video stream and then run that through my own instance of Nginx, which is like a web server, but it will be running some extra software to allow it to process video streams. I'll then have a simple web page that I can then navigate to in order to view the stream, and then I'm in complete control over the security applied to that. So let's take a look at what we need. Now all you need for this is a Raspberry Pi 3 or above. It would probably work on a Pi 02W, but especially when you're going through building the Docker container that I'll show you later, it takes quite a while. And on a Pi 0, I think it would take way too long to be practical. You then obviously need an IP webcam, and the only other thing you need is Docker. Now Docker is super easy to install on a Raspberry Pi. All you have to do is run sudo apt install -y docker docker.io docker compose and hit enter. In my case, I've already got these installed, but if you don't, that will take care of it. You then need to add the Docker group to the Pi users list of groups. And you do that with sudo usermod -a G docker Pi. After that, you just need to log out and log back into your Pi again. Once you're logged in again, just run docker ps-a, and as long as you don't get an error back, then Docker is working just fine. Now let me show you how to access the video stream direct from your IP camera. In order to determine how to access the video stream from my particular camera, I normally go to this website here. It's got a massive database of tons of different manufacturers and models of IP camera, and you can look up whichever one is relevant to you. Now if I go back to my camera's administration webpage and I go to System Settings and Device State, I can then see the model number of this particular camera, JPT3815W-HD, and it's made by Tenviz. So I can go back to the database, look up Tenviz, and I scroll down, you can see all of the different models of Tenviz camera that it supports. So if I just use the find in page functionality to look for JPT3815W, I can see that there are ways that I can pick up an individual frame, or indeed some ways to pick up a video stream. Now the one that's always worked for me is this one here, where you simply ask for the URI /11. There's also a lower quality version of the stream that's available on /12. Then I can open up VLC, and in here I just have to go to the Media menu and then click on Open Network Stream. That then opens this window here, and all I have to do is type in RTSP : and then put in the username and the password for my camera, the @ symbol, the IP address of the camera, and then that URI of /11, and then I can just hit play. As you can see here, the video stream from the IP camera is now playing successfully. And indeed, if I go back to the main page of the IP camera's website, I can control the camera using its controls. Here I can move the camera around, or I could set it into patrol mode where it will just scan round horizontally in both directions, and I can also make it do that vertically. So now we can get hold of the video stream from the IP camera. Now we can feed that into our Raspberry Pi and use some extra software in there to expose it how we want to. Now here on this Raspberry Pi, I've just installed Raspberry Pi OS 64-bit Lite. Now the first thing I want to do is grab some source code from my GitHub repository. I'll put all of the details for this down in the description, so don't feel you've got to make a note of it now. Now in my case this is going to ask me for some credentials because I haven't made the repository public yet. However, by the time you read this, it won't prompt for those credentials anymore. Now I have all the software cloned, all I have to do is move into the webcam directory. Let's take a look at some of the files in here. Now the main engine for running all of this software is a package called Nginx. And this is kind of like a web server, but it's more accurately referred to as an application server. It can be configured with all kinds of modules and plugins in order to support many different technologies. And in this case, I'm going to make use of a plugin called the Nginx RTMP module. And the file nginx_adaptive.conf is what configures that. So let's take a look at it. The first section in here just defines how many different connections you can have running simultaneously. There's then a section that describes the logging for it, and the fact that I want it to run in the foreground as opposed to in the background as a daemon. We then start to get into the definition of some of the video handling, Now, a lot of this is way beyond the scope of this video, but fundamentally the way it works is that it captures the video stream from the camera and then publishes that using a protocol called RTMP. Now, this is a pretty good video streaming protocol, but it does have some downsides. For example, it's not very good at running directly over the internet, because if there are any issues with the network at all, like you drop packets or there's a blip in connectivity, you entirely lose your video stream, so it's not very resilient. However, for use as an internal protocol, it's absolutely brilliant, and it runs with very low latency, meaning that the video is served out pretty much as soon as it is captured, and there's very little delay. This next section here looks super complicated, but it's actually not too bad. We're making use of an application called FFmpeg that will run within Nginx here, and what it's doing is it's running each of these two commands to capture both a high-res and a low-res version of the stream from the camera. Now, as we saw just now, you can do this using these kinds of URLs. And I'm providing these as environment variables into the configuration file. So that way I can keep the configuration file very generic. Once captured, it's then posting each of the streams into the RTMP engine at different locations. So the high-res version has an _full suffix to it, and the low-res version has an _low suffix to it. And for each stream, we're publishing to two different applications as independent streams. There's one here that I've called cam1_AD, and there's another one that I've called cam1_Dash. And that will become more apparent as we go through this configuration file. Now, as I mentioned earlier, RTMP doesn't work very well across the internet because it's not very resilient. In order to address this, there are two other protocols that the Nginx RTMP plugin can support and generate. One is called HLS, and the other one is called MPEG-Dash. Now, these two different protocols work in fairly similar ways, in that they construct blocks of video as individual files, each containing a specific duration of video data. You then build a collection of these chunks into a playlist, and the consuming application in the browser can then open the playlist and start playing out the video. And while it's playing out one chunk, it's then downloading the next one in the background, so it can start playing that seamlessly as soon as the first one completes. So from the user's perspective, it looks like it's just playing out an endless video stream. In the background, it's actually downloading chunk after chunk after chunk of the video, and the playlist is getting updated all the time in order to reference what the most recent chunks are. In this case, I'm saying that each video chunk will be 4 seconds long, and the entire playlist will reference 12 seconds worth of video, or 3 chunks. This is quite a nice balance, because if you have the playlist too long, then that has to be constructed before the stream can be delivered for the first time. So it actually has to capture all of that 12 seconds worth of video before it can serve out anything. And this means from the consumer's point of view, they start seeing the video stream at least 12 seconds late. In reality, there are some other delays that get baked into the system here, but you could probably expect a 15 to 18 second latency. This configuration here just defines where on the Raspberry Pi's file system the video chunks and playlist are written. Now again, MPEG-Dash is fairly similar to HLS in that it's just another video protocol that works by delivering chunks of video data. It just does so in a slightly more efficient way. And so there's normally a little bit less latency that you have to deal with. The last bit of major configuration within this file is talking about the web server component of Nginx and how it's actually serving up the web pages. In this case, it's saying that the web server is listening on port 8080, and it defines some rules that will be executed whenever the root of the website is requested. Now, I won't go through these particularly here, it's not really relevant, but it's just setting up some required HTTP headers. This next section is defining the various MIME types that can be served out of Nginx. These are HTML files, MPEG-XML files, Apple's HLS playlist files, and the actual video transport stream data. And the root defines where on the Raspberry Pi's file system these will be served out of. I then define a virtual directory called /site, which under the hood points at /mnt/pages, and I allow these to be served out as HTML files. The next thing I want to take a look at is this file called runcommand.sh. Now this takes a command to be executed as a parameter, and this will be where I call FFmpeg to read a particular video stream from my camera and then send that to an RTMP destination. There's some data that I parse out of the command that's been requested, particularly the IP address of the camera and the RTMP destination itself. I subsequently use that later in the script to determine if everything's being captured correctly. Within the main loop of the script, I check to see if an instance of FFmpeg is running that's making use of the IP address and the camera that I parsed out of the command earlier. If I find that they're not running, then I restart the process. After that, I sleep for 20 seconds, and this should be plenty of time in order to allow the stream to start being captured and served out. I then check the mnt/hls_ad directory, where I should now be writing all of my HLS stream data. If I don't find anything there, then I make the assumption that my FFmpeg instance has either hung or crashed. So just in case it's hung, I'll then kill it. The script will then loop around again and will ultimately restart it if it has crashed. This way, I can reasonably ensure that FFmpeg will just keep on running and it will get restarted if necessary. I then have two HTML files. One is to serve out an HLS version of the website, the other is to serve out a Dash version of the website. All of the initial parts of the HTML are identical, so I define some CSS information. Now the way the website works is that I'm initially going to show the low-res version of the image, and if the user clicks on it, I'm then going to make it show the high-res version of the video stream as an overlay. This way, the bandwidth can be reasonably maintained so that it's only showing the high-res when it really needs to. I'm also importing a third-party library called hls.js, and this is a wonderful piece of software that you can use with a video component inside HTML5 to play HLS video. I've then got some JavaScript here that just loads up the low quality version of the stream and starts playing it out when the page is loaded. If the user clicks to show the high-res version, then this show function is called. This just loads up the high-res version of the stream and then displays that as an overlay. Similarly, I've got a hide function that's called when the user closes the overlay, and this is used to hide the overlay and return to showing the low-res version of the stream again. The MPEG-Dash version of the HTML has pretty much the same structure to it, in that there's a couple of divs defined to show the low-res and the high-res version of the stream, and then some JavaScript that controls loading up the low-res version of the stream and playing it out, and the high-res version of the stream when it's necessary and playing it out, and also hiding that when the user closes that particular window. Now I package up all of this software as a Docker container. And in order to build the container, you just have to run this command here. Docker build -t, and then a tag to use as an identifier for your Docker container. In my case, Jeff's Pie in the Sky /webcam, and then a version number, and I just put in 0.0.1. You then put in -f, and the name of the Docker file that dictates how to build the container. In this case, it's just called Dockerfile. After that, you just put a space and a dot indicating that it should all run in the current directory. Now this will take quite a long time to run, so please do be patient. I'll come back when it's finished. Okay, so now everything's built, and the next stage is to configure the container and run it up. Now in order to configure the container, I've provided a Docker Compose configuration file. So let's take a look at that. In here, there are a few parameters that we need to set. The first is the name of the image. We just need to set that to the tag that was defined during the build. The next thing we need to do is set the username of the webcam as it's defined within the webcam system software. In my case, the user is defined as PITS and the password is password1. The next thing to define is the URI used to access the high-res stream of the webcam. In my case, the IP address of the webcam is 192.168.100.152 and then the path is 11. I then need to do the same for the low-res URI, and that's the same IP address /12. After this, everything's all set up, so I just need to save this, and now we can run up the container. In order to run the container, I just have to run this command here, docker-compose -f webcams.compose up -d. And I can prove that's running with docker ps -a. And here you can see it's been up 9 seconds. Now the container's running, I can go back to VLC here, and I can again click on Media and Open Network Stream. And this opens the same dialog as last time. Here I can now connect to the RTMP output from the Docker container. So I can go RTMP : 192.168.0.30, which is the IP address of my Raspberry Pi, :cam1-cam1_ad/cam1_ad_full. And if I return back to my VLC window now, you can see that that is playing. And so this is actually coming out of the Docker container, which is taking the feed in from the webcam and is now presenting it as an RTMP stream. Equally, back in my browser, I can now open a new tab and I can navigate to 192.168.0.30/site/index.html, and here we can see the HLS version of the stream. Now if I open up developer tools in this window and we go to network, here you can see the individual video segments being requested along with the playlist, and it's just ticking up each time playing the next video segment. I can also go to the Dash version just by changing the URL to dash.html, and here you can see the Dash version of the same video stream. And now, since all of this is running out of Nginx, I have complete control of how I access this and what security to apply to it. So for example, I could configure Nginx to ask for a username and password, or I could configure it to use certificate-based authentication. Or I could leave it alone entirely and instead use a VPN to connect back to my home network and then access the stream that way. All of these would be completely secure ways of then accessing my video data rather than using the website that is built into the IP camera itself or a third-party application that I'd then have to feed the video stream into in order to see it externally. Our digital security and privacy are more important now than they've ever been. And so it's really important that you make sure that you have complete control over your data. Now for me, that also includes any video streams that I'm collecting here at home from any video source. I don't want to just make that available to anybody, and I don't necessarily trust some of the third-party applications that can be used to expose webcam information. By using Nginx here and the Nginx RTMP module, I've been able to secure my own access to my own streams and control exactly how I view them. So it gives me that extra peace of mind. But that's it for this video. If you like what you've seen here, please click that thumbs up button, subscribe to see more, and also hit that notification bell to be told when I put a new video out. In the comments, let me know how you got on with this. And once again, if you've got any ideas for other projects you'd like to see me do in the future, let me know in there as well. Thanks so much for watching till the end, and until next time, bye for now.